Students, welcome to the video number 6. In this video, I'm going to solve the problems on dielectric. Before solving the problems, you should know the synopsis part of it. What are the formulas comes into play? First equation, P equal to N into mu. What is mu here? Dipole moment. What is N here? Number of atoms per unit volume. Number of atoms per unit volume. So that this unit is what? Suppose dipole moments. How to write dipole moment? Polarization equal to what? Polarization equal to number of dipole moment per unit volume. This is the formula. Dipole moment formula equal to what? Coulomb meter. Volume formula is what? Meter cube. 1m, it cancels, so that the unit is coulomb per meter square. That is coulomb per meter square. Is the unit of what? Unit of the polarization. Okay. Second one, that is here. Another equation, P equal to epsilon naught into what? Epsilon r minus of 1 into what? E. This is the formula. What is E? E is the electrical field. Epsilon r is nothing but dielectric constant. It is called dielectric constant or relative permeability. Sometimes he will give the electric potential, he will give that. So that you have to use the equation E equal to V divided by D. What is D? D is the thickness of the material. V is the what? Electric potential, that is. So that we can write P equal to epsilon naught into epsilon r minus of 1 into what? V divided by D. This is the formula. Next, third one. Susceptibility equal to epsilon r minus of 1. This is the formula. Since relative permittivity or dielectric constant has no unit, and hence the susceptibility is also, it has no unit in it. Here it is called as electric susceptibility. But in magnetism chapter, it is called as magnetic susceptibility. Next one, fourth. Alpha E equal to alpha E is called as electronic polarizability. It is epsilon naught into what? Epsilon r minus of 1 divided by what? Yeah, this is the formula. Electronic polarizability. Here, this formula you have to use for this to calculate the electronic polarizability for the materials like important point. This is to be used for helium, neon, argon. If the substance is helium, neon, argon, krypton, so on, where what happens? They are the non-polar molecules and they have no permanent electric dipole moment and all that. This, remember, this is very important formula when you use. Next, one more formula is there. It is a Clausius-Massuti equation. It is epsilon r minus of 1 divided by epsilon r plus of what? 2 epsilon r minus of 1 divided by epsilon r plus 2 equal to n into alpha E divided by what? 3 of what? Epsilon naught. Students, this formula you have to use. This formula you have to use the materials like sulfur, diamond, any carbon atoms. You have to use this equation. This formula you have to use absolutely for the helium, neon, argon, krypton and all that. Here, possibility is what? He will give the value of N, alpha E. Epsilon naught is the constant. N is known, alpha E is known and epsilon naught is that. But you are supposed to calculate sometimes epsilon r equal to 1. This is one type of problem. Second type problem is what? He will give the value of epsilon r epsilon naught is constant and n is given, but you need to calculate what? Alpha E equal to what? Alpha E equal to what? This is the point. The unit of alpha E nothing but electronic polarizability. This unit is F m to the power 2, F m to the power 2. It is Farad. Right. It is a 4-mark question, but he will not give the value of n directly. But n you have to calculate using the formula. You did several problems in this in previous semester also. N equal to Avogadro's number into density divided by, that is weight of the substance, molecular weight. It is called as molecular weight. Oxygen molecular weight is what? 32. That is oxygen molecule, like that. Hydrogen molecule 2, like that. And here n equal to 6.023 into 10 to the power 26 into density divided by what? It is molecular weight. Suppose the molecular weight is 32, you write only 32. And density, look into that, the given data. Has he given in the grams per centimeter cube or what, kg per meter cube, that is. Suppose the density is like this, 42 gram per centimeter cube, if it is a given form. Don't use this, but in this calculation, density equal to 42 into 10 to the power of 3 years. That is a kg per meter cube. Kg per meter cube. This is the formula for, that is what, density. You have to multiply by 10 to the power of 3. Okay. Now with this idea, now we shall proceed it here. What is the unit of alpha E? The unit of alpha E is what? Farad meter square. F m to the power 2. This susceptibility, it has no unit and all that. Once again repeat, P is nothing but polarization. Polarization equal to what? Number of atoms per unit volume. mu is the what? Dipole moment. What is the unit of this? Coulomb per meter square. Another formula is what? P equal to epsilon naught, epsilon r minus of 1 into what? E. Sometimes you will give the electric potential, you will give that. Suppose if I have given the electrical field, no problem. Otherwise, if there is a potential is there, then you will give the thickness E equal to V by what? D, that is. This is a formula. Next one is, this unit is again Coulomb per meter square, Coulomb per meter square. This susceptibility, it has no unit. And there are 2 formulas are there for electronic polarizability. This formula you have to use. Where you have to use? If the given substance is helium, neon, argon and all that. And this is the closest Mossadi equation. This formula you have to use other than this helium, neon, argon. That formula you have to use it. Here there are 2 possibilities. Here you give the value of alpha E, n, you may ask you to calculate what? Epsilon r. Or you know the value of epsilon r, n is known here, then epsilon naught is known, and then you're supposed to calculate what? Alpha E and all that. Okay. Now with this idea, now I will proceed. First problem. Okay. Now problem number 1. I have written all the list of formulas I have written here. Calculate the polarization produced and susceptibility in a crystal. I have to calculate polarization and also what? Susceptibility. When an electric field of 3 volt per centimeter is applied across a dielectric and its dielectric constant is 10. Okay. First write what are the given parameters. Given parameters. Meters. Next is to be calculated. What are the given parameters? Here there is electrical field is there. E equal to 3 volt per centimeter. Then dielectric constant epsilon r equal to what? 10. What to be calculated here? I need to calculate polarization and also what? Susceptibility. P equal to what? And susceptibility equal to what? Okay. Always whenever the data is given, after that, please look into it, whether are they all in SI units or not. No. But here you see, it is volt per centimeter. No? Then I will write like this. 3 into 10 to the power of 2 volt per meter, because I am converting centimeter to what? Meter. For that, 1 by 100. That means it comes around what? 3 into 10 to the power of 2, because centimeter is in what? Denominator. This. Next, what to be calculate? Polarization equal to what? And susceptibility equal to what? Look into the formula. This. Here, epsilon naught, normally they will give the constants, they will give, that is epsilon naught equal to 8.85 into 10 to the power of 4 minus 2. This is the formula for the epsilon naught. Okay. Substitute, can I use this equation here? Electrical field is there, epsilon r is there, and epsilon naught is there. Now I will use the formula P equal to, what is this? P equal to epsilon naught into epsilon r minus of 1, epsilon naught is the subscript, into what? E absolute. P equal to, substitute, 8.85 into 10 to the power of what? Minus 2. This is 10 minus of 1 into 3 into 10 to the power of what? 2. This P equal to 8.85. 10 minus of 1 is what? 9. Into what? 3. Here it is minus 12 is there, here it is plus 2. It is 10 to the power of what? Minus 10 and all that. After substituting all these values and then using calculator, just to calculate what are the values, this turns to be P equal to 2.38 into 10 to the power of what? Minus 8. Minus 8. This is the polarization. Next, being a physics student, you should write the units for it. The unit is coulomb per meter square. This is the polarization. Next, supposed to calculate what? Susceptibility equal to what? What is the formula for susceptibility? Equal to epsilon r minus of 1 equal to epsilon r minus of 1. This is equal to, what is epsilon r here? 10. 10 minus of 1 equal to what? 9. Of course, no unit for it. I hope that is clear for you guys. Next. Now, read the problem 2. What is the polarization produced in a sodium chloride? Substance is sodium chloride. By an electric field has given electrical field of 600 volt per millimeter, and dielectric constant is what? 6. It is exactly similar to the previous problem. Right. What are the given parameters? Given parameters to be calculated. First, electrical field equal to what? 600 volt per millimeter. Dielectric constant epsilon r equal to what? 6. Okay. What to be calculate? The polarization equal to what? Here I told you that is, first you should think it whether the given data are exactly, are they in SI units or not? No, it is not in SI unit, so that I am writing E equal to 600 into 10 to the power of 3 I am writing. In the previous problem I converted centimeter to meter, but here I am converting the millimeter to what? Meter I am converting. It is 600 into 10 to the power of what? 3. This is this one. Next. Here, this is equal to 6 into 600 minus this one, 6 into 10 to the power of 5. It is, the unit is volt per meter. This is the volt per meter. Everything is correct. Now, that's the data. Now, what to be calculated here? Polarization. Now, I will use the formula. Polarization equal to polarization solution. polarization equal to epsilon naught into epsilon r minus of 1 into what? E. Substitute this. P equal 8.85 into 10 to the power of minus 12. It is epsilon r is 6 minus of 1 into electrical field is 6 into 10 to the power of what? 5. It is 6 into 10 to the power 5. This P equal to 8.85 into 5 into what? 6 into 10 to the power of what? Minus 7, because it is minus 12 and here it is what? Plus 5, and it is all turns out to be, it is I think it is 8.85 into what? 30 into 10 to the power of what? Minus 7. So that I will multiply with this. 3 5s are 50, 3 8s are 24 plus 1 25, 3 24 plus 2 20, 26.55 into 10 to the power of minus 6, because here this 1 0 is there. This is 26.55 into 10 to the power of 4 minus 6. What is the unit? It is coulomb per meter square. Of course, is asked only polarized, but you can calculate. Suppose if they ask for susceptibility, that also you can calculate. Susceptibility equal to epsilon r minus of 1 equal to 5. It is 6 minus 1 equal to 5, and it has no unit in it. This is problem number 2. I solved one type of problems. I solved. Next one is, this comes under second type of problem. This comes under what? Third type of problem. Only there are 3 types of problems are there in the dielectric chapter. If you are familiar with all the 3 types of problems, definitely the 4 marks in your pocket. Okay. Students, now look at the problem number 3. It is a different type problem. The dielectric constant of the helium gas is 1.000684. Calculate the electronic polarizability if the helium gas contains 2.7 into 10 to the power of 25 atoms per meter cube, and hence calculate the radius of the atom. Okay, fine. First read the problem and write down what are the given parameters. Given parameters to be calculated. Simple problem. Dielectric constant has given epsilon r equal to 1.00040684. Okay. Then number of atoms n has given 2.7 into 10 to the power of 25 atoms per meter cube. Okay, these are the 2 given data. What to be calculated here? Polarizability, that is alpha E equal to what? Electronic polarization. Let us use the word electronic polarization. And then the radius equal to what? Radius of the atom. Now look at it. Epsilon r has given, n has given, alpha E is to be calculated. It is for the which gas here? Helium. I told you that is in the beginning in the synopsis part. Here also electronic polarizability alpha is also is there. Here also it is there. Which equation you have to use? This is the problem. Student, use this formula for helium, neon, argon, krypton, whatever. Use this formula. Now you see alpha E equal to epsilon naught epsilon r minus of 1 divided by what? N. That is okay. Alpha E equal to epsilon r, we know that 8.85 into 10 to the power minus 2. Epsilon r 1.040684 minus of what? 1 4 divided by n. It is 2.7 into 10 to the power of what? 25. Substitute all the data. Then here 8.alpha E equal to 8.85. 1.00 minus 1 equal to 0.000684 divided by 2.7. This part. into 10 to the power. Here it is minus 12, here it is plus 25. You bring it as numerator, it becomes what? Minus of what? 37 and all that. If we calculate all this by using the calculator, it turns out to be 2.24 into 10 to the power of 4 minus of what? 41. It is, the unit is a farad meter square. This is the formula. And one more to be calculated here, radius. This radius, of course, I have written here, r equal to alpha e divided by 4 pi epsilon naught raised to what? 1 by 3. This is the formula. But we can calculate this not by using ordinary calculator, only by the scientific calculator we can do it, because it is raised to what? 1 by 3. Alpha e is now already calculated. Then substitute this and then calculate what r you can calculate. Now for calculate r, substitute r equal to 1 divided by 4 pi epsilon naught into what? Alpha e raised to what? 1 by 3. But we know that in the PUC also 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power of 9. Remember that. 9 into 10 to the power of 9. Alpha e you calculated 2.24 into 10 to the power of what? Minus 1 raised to what? 1 by 3 and all that. Here it turns to be, it is nearly equal to 0.53 Armstrong. Armstrong means 10 to the power of what? Minus 10 and all that. But here 41 minus 9, it becomes how much? It is 50. It is difficult to calculate 1/3 of it. Just rearrange itself. You make it divide by 3. It should be divisible by what? 3. You make it the power, that is. Suppose if you make it 41 minus of 9, it comes around how much? 37. 41 minus of what? 9. It comes around 32, that is. Okay, 32 is now divisible by 3. You make it 33, you make it power 33 by adjusting the decimal number and all that. Or else, with the using scientific calculator, easily you can calculate. This is another type, second type of problem. Okay, so it is problem number 4. Read it. Calculate the electronic polarizability of the xenon atom. Xenon means again it is inert gaseous. Polarizability. I told you this equation. This equation is exclusively for the what? Inert gaseous light. Inert gases all are where there is positive charge and negative charges, both are coincided, so that the permanent dielectric moment is, dipole moment is what? 0 in that material. Okay, use this equation. If the dielectric constant is as given, that is given parameters. Given parameters to be calculated. What are the given parameters here? The given parameters is dielectric constant means epsilon r equal to 1.874 and capital N has given it is 6.42 into 10 to the power of 5. What to be calculated? Electronic polarizability. Only he is asking for the electronic polarizability. Yes. Which equation? This equation. It is 99% the problem is over now. Only alpha e equal to epsilon naught into epsilon r minus of 1 divided by what? Yeah. Alpha e equal, it is 8.85 into 10 to the power of what? Minus 2. Epsilon r 1.874 minus of what? 1 divided by n value 6.42 into 10 to the power of what? 5. Substitute all the values. Here alpha e equal to 8.85 into 0.874 divided by 6.42 into here minus of what? 70. Which is Oh, 25 is 25. Means it is what? Minus of 37. Using calculator, calculate all this data. Then it turns to be alpha E equal to 1.205. 205 into 10 to the power of what? Minus 37. This is the value of alpha. What is the unit of this? Farad meter square. Farad meter square is the unit of what? Electronic polarity. Otherwise you lose 1 mark, students. And it may carry 2 or 3 marks. Sometimes may ask you to calculate the radius also. Simple. Whatever the value of alpha is there, substitute here, and 1 by 4 pi epsilon naught value, you know that 9 into 10 to the power 9, and then calculate. This is a second type of problems. Now I will concentrate on this. How to make use of Clausius-Moissault equation. Okay. Students, now read the problem. The atomic weight and density of carbon atom, it is not helium or neon, then you have to use this equation, are 12 and 3.52. Okay, what are they given here? Atomic weight has given, atomic weight is 12, and what is the density has given here? 3.52. Okay, atomic weight, I am writing W equal to 12, density equal to rho equal to, it is 3.52, but unit is grams per centimeter cube. You need to convert into what? Kg per meter cube into 10 to the power of 3. However, now they don't ask, it's all preliminary basic things. And that alpha E equal to 0.917 into 10 to the power of minus 40 Farad meter square. These are the given data. What to be calculated here? Dielectric constant epsilon R equal to what? Okay, fine. I will use this equation. I will use that. This is a epsilon Clausius-Moissault equation I am using. This equation I am using. Okay. Epsilon R minus of 1 divided by epsilon R plus 2 equal to n into alpha E divided by 3 epsilon naught. Of course, now I need to calculate epsilon R. Alpha E is now, epsilon naught is now here. But do you know the value of En here? No. But here he has given the density. Here how to calculate the value of N? For this, use this equation. That is N equal to, first calculate N. N equal to Avogadro's number into density divided by what? W. This value of N equal, Avogadro's number, 6.023 into 10 to the power of 4, 26 I am writing. Directly in a silent I am writing. Into density, it is how much it is? 3.52 into 10 to the power of 3. It is kg per meter cube. Divided by atomic weight is 12. Directly you can write. Don't know, no need of any conversion. Some books what they have written is, here they have written 23, here they have written 10 to the power of minus 3. Again it becomes what? 26 it becomes. You follow any one method, you follow it. I am writing this I am writing what? 26 I am writing. Substitute all these values. Here, this is equal to N value equal to, it comes out 1.766 into 10 to the power of what? 29 atoms per meter cube. That's what? Atoms per meter cube. It is the value of what? N. I got the value of N. I know the value of alpha E. Then epsilon naught is now. Now you can calculate what? Epsilon R you can calculate. Yes. What is the value of N here? N equal to 1.766 into 10 to the power 29 meters. Substitute this. Now I'll run it. Okay. Epsilon r minus of 1 divided by epsilon r plus 2 equal to 1.766 into 10 to the power of 29. What is the value of alpha? You know that. 0.917 into 10 to the power minus 40. 3 into 8.85 into 10 to the power minus 12. Epsilon naught value, you should know that. It's just like the speed of light, how you are remembering now. In the same fashion, you have to remember it. Now, this value, it comes around 1.766 into 0.917 divided by, that is 3 into 8.85 into 10 to the power, say, minus 12, you bring it numerator, plus 12, that it becomes what? 10 to the power of what? 41. This is 10 to the power of what? Minus of what? 40. You are getting only what? Plus 10. 10 to the power of 1 you are getting. Then it is translates into all these values. It comes around 0.609. It is epsilon r minus of 1 divided by epsilon r plus 2 equal to 0.609 and all that. Now you have to do the cross multiplication here. I will repeat this part. Yes. Epsilon r minus of 1 equal to epsilon r plus 2 into 0.609. Epsilon r minus of 1 equal to epsilon r into 0.609 plus you multiply it. 2 9s are 18, 1, it is 2 6s are 12, it is 1.218. Okay, this term I am bringing here. It is epsilon r minus epsilon r into 0.609 equal to 1.218. This minus 1, I will bring it on the right side. This is epsilon r is the common factor. 1 minus 0.609 equal to 2.218. Now subtract. This is equal to epsilon r into 0.319 or what? 391. It comes out 0.391 equal to 2.218. Therefore, epsilon r equal to 2.218 0391. Substitute. It turns to be, it is more than 5 or something. It is 5.64. Yes, it is 5-mark question. Don't write an unit because epsilon r is a dielectric constant and it has no unit end of that. Because we know that dielectric constant equal to epsilon divided by what? Epsilon naught. Get to the point. This is the dielectric constant. It is type 3 problem. Okay. Next, one more problem we'll solve on this type 3 problem. Okay, so read the problem. Sulfur is elemental solid dielectric. Here the given element is sulfur. In the previous problems, probably sodium chloride or something else. Carbon in the previous problem. Dielectric, whose dielectric constant is 3.4. Dielectric constant has given. Dielectric constant. It is epsilon r equal to 3.4. Calculate the electronic polarizability alpha E equal to what? And other data rho has given 2.07 into 10 to the power of 3 kg per meter. No need to conversion. And its atomic weight is given equal to 32.07. Yes. This you have to formulate use. This one is what? Clausius-Moissac equation. To calculate this value alpha E, has given epsilon r is given, epsilon naught of course standard, but I don't know the value of n. How to calculate the value of n? Using this formula. N equal to, first calculate n, equal to Na into rho divided by W. N equal to, you have got a number 6.023 into 10 to the power of what? 26. Density equal to 2.07 into 10 to the power of 3 divided by atomic weight directly 32.07. You substitute. This comes around, it is this value of m equal to 3.88 into 10 to the power 28 atoms per meter cube. This is the value of n. I will substitute the value of n and then calculate what is asking for what? Alpha e. Okay. Now I am writing n equal to 3.88 into 10 to the power of what? 28. Okay. Now substitute all this data in this equation. Okay. Epsilon r minus of 1, epsilon r plus of 2 equal to n alpha e divided by 3 into what? Epsilon naught. Okay. Substitute the values. What is the value of epsilon r? 3.4 minus of 1. 3.4 plus of 2 equal to n value 3.88 into 10 to the power 28 into what? Alpha e, it is alpha e divided by 3 into 8.85 into 10 to the power minus 2. Substitute all this. This is 2.4 divided by 5.4 equal to this quantity. Using calculator you do it, 3.88 and all. It comes around 0.146 into, this is minus 12, bring it to the numerator, it becomes what? 10 to the power of 40 into what? Alpha e. 2.4 divided by this one, it turns to be 0.314 equal to 0.146 into 10 to the power of 40 into what? Alpha e. Substitute. Now calculate alpha e. Therefore alpha e equal to therefore alpha e equal to 0.314 divided by 0.146 into 10 to the power of 40. This value, electronic power, it comes to be 3.03 into 10 to the power of minus 20. Electronic polarizability. What is the unit? F m to the power farad meter square. Okay, students, I completed your 100%. Whatever the syllabus is allotted for me, I completed 100% with all the problems. Suppose if you have any doubts and all that, now please you can chat me in the WhatsApp and all that. Then I will clear your doubts and all that. It is sincerely I completed all my allotted syllabus. It is left to you how you are utilizing all these video lectures and all that. The probably one GM count or some definitions are there that I will be able to complete in the by notes or something. I'll complete it. That's all that is. Thank you. One and all that is.